Show that z square plus 2z is analytic. So what we have to prove is, we have to prove that this function is analytic. In other words, it satisfies Cauchy-Riemann equations. So z square plus 2z, it satisfies CR equation that has to be verified. For that, f of z equals z square. In place of z, you have to substitute x plus iy, so that you will get x plus iy whole square plus 2 into x plus iy. Now you have to expand x plus iy whole square. You will get x square. Iy whole square is minus y square because y square is minus 1, plus 2ixy plus 2x plus 2iy. Grouping the real and imaginary parts separately here, what you will get is x square minus y square plus 2x, x square minus y square plus 2x plus I into 2xy plus 2y. This is of the form u plus iv. This is of the form u plus iv, where u is x square minus y square plus 2x and v is 2xy plus 2y. So delta u by delta x is 2x plus 2, and delta v by delta u by delta x, you have to differentiate u partially with respect to x. If you differentiate partially with respect to x here, x square differentiation is 2x, y is constant, therefore its differentiation is 0, and 2x differentiation with respect to x is 2. Similarly, partial derivative of v with respect to x, delta v by delta x, is keeping y constant. You will get 2y into differentiation of x is 1, that is 2y. 2y is a constant, therefore its differentiation is 0. Similarly, partial differentiation of u with respect to y, keeping x constant. So x square is constant, therefore its differentiation is 0, minus 2y. Similarly, 2x is constant, its differentiation is 0. So delta u by delta y is minus 2y. And delta v by delta y, you have to differentiate v with respect to y, keeping x constant, you will get 2x plus 2. So these are the four partial derivatives of u and v with respect to x and y. Now we have to verify CR equations, that is Cauchy-Riemann equations. So delta u by delta x, is it the same as delta v by delta y? Yes. So therefore, here delta u by delta x equal to delta v by delta y, and delta u by delta y equal to minus delta v by delta x. So therefore, these two are satisfied here. So therefore, the CR equations are satisfied here. Hence, the function is analytic. That is, CR equations are satisfied. Hence, the given function is analytic. Next, another problem. Show that f of z equals sin z is analytic. Show that f of z equals sin z is analytic. So what is sin z? It is sin of x plus iy, because z is x plus iy. On expansion of sin of a plus b formula, sin of a plus b formula is sin a cos b plus cos a sin b. So here sin x into cos iy plus cos x into sin iy, because sin a cos b plus cos a sin b. But cos iy is cos hyperbolic y that I have given you, in 2 or 3 classes before. That is sin x into cos hyperbolic y plus I cos x. Remember, sin hyperbolic y is nothing but sin iy. So sin iy can be written as I sin hyperbolic y. You have to remember this. Cos iy is always cos hyperbolic y. Sin iy is I sin hyperbolic y. So that it is of the form u plus iv. Here u is sin x cos hyperbolic y and v is cos x sin hyperbolic y. Because separating the real and imaginary parts here, the real part u equal to sin x cos hyperbolic y, and V equal to cos x sin hyperbolic y. Next, in order to verify CR equations, delta u by delta x, you have to differentiate u with respect to x, keeping y constant. That is, cos hyperbolic y is constant here. Therefore, differentiation of sin x is cos x. So it is cos x into cos hyperbolic y. Delta v by delta x, keeping y constant here. Differentiation of cos x is minus sin x into sin hyperbolic y, because sin hyperbolic y is constant while differentiating with respect to x. And partial derivative of u with respect to y is sin x into sin hyperbolic y. Remember, you are differentiating with respect to y, keeping x constant. So it is sin x into differentiation of cos hyperbolic y is sin hyperbolic y. Delta v by delta y is cos x into differentiation of sin hyperbolic y is cos hyperbolic y. You will notice here that the CR equations are satisfied. So it is true here that the CR equations, what are the CR equations here? It is delta u by delta x and equal to delta v by delta y, and delta u by delta y equal to minus delta v by delta x. Hence, f of z is analytic because CR equations are satisfied. Next, we shall show that. So what is that one? F of z equals log z is analytic. Also find f dash of z. Here the problem f of z is log z. What I have to prove? It is analytic, and also we have to find its derivative, that is f dash of z. Now f of z is log z equals log of x plus iy. So our z is what? X plus iy. So it is log z equals log of x plus iy. I have given you earlier that what was given is, if z is x plus iy, log z expansion is half log of x square plus y square plus I into tan inverse pi by x. You have to remember this. So this expansion was given earlier. Log z expansion is half log of x square plus y square plus I into tan inverse y by x. What I had given you earlier is separate into real and imaginary parts of log z. So I have separated this as real and imaginary parts. That is indicated again in the square bracket. That is, log z expansion is log of x plus iy. That is log of r cos theta plus I sin theta. That is log r plus log of m into n form. This is if we take r common there. So log r plus log of e raised to I theta. Log r plus log of exponential base to the same base. That is I theta. Therefore, log r is the modulus of a complex number. That is square root of x square plus y square. Theta is tan inverse y by x. That is the amplitude here. So therefore, you will get u equal to half log of x square plus y square, and v is tan inverse of y by x. Now you have to differentiate partially with respect to x. So delta u by delta x is half of. Differentiation of log is 1 by x square plus y square. Differentiation of u with respect to x, keeping y constant, is x square plus y square. Differentiation is 2x. So here 2 cancels. You will get x divided by x square plus y square. And delta v by delta x is differentiation of tan inverse is 1 by 1 plus y square by x square into differentiation of y by x with respect to x, keeping y constant. Remember, y is constant, keep y as it is. Differentiate 1 by x. What is differentiation of 1 by x? It is minus 1 by x square. So on simplification, because if we take the LCM here is x square, that comes in the numerator, and that x square cancels. You will get minus y divided by x square plus y square. Similarly, delta u by delta y is, it is y divided by x square plus y square. You can verify this. And delta v by delta y, it is tan inverse differentiation is 1 by 1 plus y square by x square. Differentiation of y by x with respect to y. Remember, x is constant now. that is 1 by x is constant into differentiation of y is 1. So we'll get 1 by x. Again, taking the LCM, 1x cancels here. You will get x divided by x square plus y square. What do you say about the CR equation? Delta u by delta x is x by x square plus y square. And delta v by delta y, that is also x by x square plus y square. So these two are equal. Similarly, delta u by delta y is y by x square plus y square. And delta v by delta x is minus y by x square plus y square. In other words, the second equation of CR equation, delta u by delta y equals minus delta v by delta x, that is also satisfied. That is, both the equations of Cauchy-Riemann, that is CR equations, are satisfied. Hence, f of z equals log z is analytic. Here you are required to find f dash of z. F dash of z. But f dash of z is given by delta u by delta x plus I into delta v by delta x. In the course of the proof of analytic function, that is derivation of CR equations, we have got this result in the proof of CR equations derivation. F dash of z equals delta u by delta x plus I into delta v by delta x. What is value of delta u by delta x? So delta u by delta x value is x divided by x square plus y square. That is being substituted here, plus I. For the value of delta v by delta x is minus y by x square plus y square. Take the LCM. What is the LCM? X square plus y square. But you can write x square plus y square as x plus iy into x minus iy. If you multiply x plus iy into x minus iy, you will get x square plus y square. In the numerator, we have x minus iy. So x minus I gets cancelled. You will get 1 by x plus iy. But what is x plus iy? 1 by z. That is, differentiation of log z is 1 by z. So the problem what we are having is find f dash of z. So our derivative of f of z with respect to z, that is f dash of z, is 1 by z, that is being evaluated here. Next, we shall go to the definition of harmonic functions and some theorems on harmonic functions. So harmonic function is very important. So in view of the examination. So what the definition states is, a function u equals u of xy is said to be harmonic. A function u equals u of xy is said to be harmonic in a domain D if second order partial derivative of u with respect to x plus second order partial derivative of u with respect to y equals 0 in the domain D. So here delta square u by delta x square is nothing but you have to differentiate u partially with respect to x twice plus partial differentiation of u with respect to y twice. If you add those two, if you get 0, then we say that the function u of xy is harmonic. So we denote the delta square u by delta x square. Remember, it's not dx square, but it is delta x square plus delta square u by delta y square. It is always denoted by delta square u. It is like something like Laplace operator. So it's a differential operator. So it's like del operator. So it is del square u. So what is del square? Del square is nothing but d square, delta square by delta x square plus delta square by delta y square. When operated on u, we will get delta square u by delta x square plus delta square u by delta y square. So if this equation, this is also called a Laplace equation. So this equation, delta square u, that is by x square plus delta square u by delta y square equals 0, is called Laplace equation. So a function is harmonic if it satisfies Laplace equation. So if the Laplace equation is satisfied, then the function is harmonic. Check whether, let us have an example now. Check whether u of xy equals x square minus y square is harmonic. U of xy equals x square minus y square is harmonic. First, we shall find the partial derivative of u with respect to x. Keeping y constant, you will get 2x. Similarly, partial derivative of u with respect to y, Keeping x constant, it is minus 2y. Partial differentiation of delta u by delta x, you have to differentiate delta u by delta x once again with respect to x. You will get delta square u by delta x square. Its differentiation is 2. Again, differentiate partially with respect to u, delta u by delta y once again. With respect to y, if you differentiate, you will get delta square u by delta y square. If you differentiate minus 2y with respect to y, you will get minus 2. Next, you have to add these two so that you must get 0 if it were to be harmonic. So, if you add delta square u by delta x square plus delta square u by delta y square, you will get 2 plus of minus 2 is equal to 0. Therefore, the given function u of xy equals x square minus y square is harmonic. So, therefore, for a harmonic function, u of xy, x square minus y square, we should satisfy Laplace equation. What is that Laplace equation? Delta square u by delta x square plus delta square u by delta y square. That should be equal to 0. Now, I shall ask one of the participants. Okay, wait. I shall select anyone of. First, who will answer for my question? I want to ask one question. Who will answer? Srinidhi? Srinidhi? Could you hear now?
Yes, sir.
Yes. Now write u equals 2xy. You take another example. U equals 2xy. Okay. What is partial derivative of u with respect to x here? Keeping y constant?
2y.
Good, right. Again, differentiate.
2y.
Yes, 2y, right. Again, differentiate that with respect to x again.
0.
0. Okay, one thing is over.
0.
Delta, yes, you are right. Delta square u by delta x square is 0. You are absolutely right. Hage, you have to differentiate u with respect to y.
2x.
2x, right. Differentiate once again.
2x.
Yes, 2x, right. And then differentiate once again with respect to y.
0.
Add those two
0,
zeros.
sir.
0. Is it harmonic?
Yes, sir.
Yes. Thank you.
Yes, sir.
Okay, right. So therefore, if you take another example, v equals 2xy, that function is also harmonic. I can give many problems. Better you list out those problems and take it as an exercise, all of you. I have not listed here, but I will tell you orally now. You please list down and check whether they are harmonic. First one, u equals half log of x square plus y square. U equals half log of x square plus y square. So will you verify it? Next. U equals tan inverse y by x. That is also harmonic. U equals tan inverse y by x. That is also harmonic. You can check this. And similarly, u equals x. That is also harmonic. U equals just x. That is also harmonic. Okay, next, let us take one theorem. So this is an important theorem to ask many times in the examination again. The real and imaginary parts of an analytic function are harmonic. The meaning of this is, if you have a function f of z equals some u plus iv, that function is analytic. If I say that it is analytic, it satisfies CR equations. Anything that satisfies CR equations, then its real part and imaginary parts must be harmonic. Now let us cite one example. Suppose z square is the z square, that is x plus iy whole square. X plus iy whole square and expansion, you will get x square minus y square plus 2ixy. This function is analytic. Is it true? Z square is analytic. Tell me, z square is analytic, you have verified earlier. Tell me, what is the real part of z square? ಯಾರಾದರೂ ಒಬ್ಬರು ಅನ್ಮ್ಯೂಟ್ ಮಾಡಿ ಹೇಳಿ. Real part of z square.
X square minus y square.
Is it harmonic? ಈಗಷ್ಟೇ ಮೇಲ್ ಮಾಡಿದೇವಲ್ಲ.
Yes, sir.
Yes. What is imaginary part? Imaginary part of z square ಏನು?
2xy.
Is it harmonic? ನೀವು ಯಾರೋ ಒಬ್ರು ಚೆಕ್ ಮಾಡಿದಿರಲ್ಲ. ಚೆಕ್ ಮಾಡಿದಿರಿ ಆಗಲೇ. Somebody has checked this. So that is harmonic. Andre? Yes. Okay. 2xy. That is also harmonic. ಅಲ್ಲಿಗೆ z square is analytic. ಅದರ ರಿಯಲ್ ಪಾರ್ಟ್ ಯಾವುದು? x square minus y square. ಅದು ಹಾರ್ಮೋನಿಕ್ ಅಂತ ಮೇಲ್ಗಡೆ ನೀವು ಈಗ ಎಕ್ಸಾಂಪಲ್ ಅಲ್ಲಿ ನೋಡಿದ್ದೀರಿ. 2xy is harmonic ಅನ್ನೋದನ್ನ ಶ್ರೀನಿಧಿನೋ ಯಾರು ಪ್ರೂವ್ ಮಾಡಿದ್ದಾರೆ ಈಗಾಗಲೇ. So therefore the real part is harmonic. Imaginary part is also harmonic for this analytic function. ಯಾವ್ದು analytic function? z square. Z square analytic ಅಂತ ಹಿಂದೆಲ್ಲೋ ಪ್ರೂವ್ ಮಾಡಿದ್ದೀರಿ. ಹೇಗೆ? Using CR equations. CR equation satisfy ಮಾಡುತ್ತೆ, ಅದರಿಂದ ಅನಾಲಿಟಿಕ್ ಅಂತ ಹಿಂದೆಲ್ಲೋ ಪ್ರೂವ್ ಮಾಡಿದ್ದೀರಿ. ಬಿಕಾಸ್ ಇಟ್ ಈಸ್ ಅನಾಲಿಟಿಕ್, ಅದರ ರಿಯಲ್ ಪಾರ್ಟ್ ಮತ್ತೆ ಇಮ್ಯಾಜಿನರಿ ಪಾರ್ಟ್ ಇದೆಯಲ್ಲ, ದಿ ರಿಯಲ್ ಪಾರ್ಟ್ ಇಸ್ ಎಕ್ಸ್ ಸ್ಕ್ವೇರ್ ಮೈನಸ್ ವೈ ಸ್ಕ್ವೇರ್ ಅಂಡ್ ಇಮ್ಯಾಜಿನರಿ ಪಾರ್ಟ್ ಇದೆಯಲ್ಲ 2xy, ಬೋತ್ ಆರ್ ಹಾರ್ಮೋನಿಕ್. ಹಾರ್ಮೋನಿಕ್ ಅಂದ್ರೆ ಇಟ್ ಸ್ಯಾಟಿಸ್ಫೈಸ್ ಲ್ಯಾಪ್ಲೇಸ್ ಈಕ್ವೇಶನ್. ದಿಸ್ ಈಸ್ ದಿ ಮೀನಿಂಗ್ ಆಫ್ ದಿಸ್ ಥಿಯರಮ್. ಸೊ ಆಫ್ಟರ್ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡಿಂಗ್ ದಿ ಮೀನಿಂಗ್ ಆಫ್ ದಿಸ್ ಥಿಯರಮ್ ಹಿಯರ್, let us go to the proof. So what the theorem states? Real and imaginary parts of an analytic function are harmonic. Andre real part is also harmonic, imaginary part is also harmonic. That is, in that example you can notice x square minus y square is also harmonic, 2xy is also harmonic because the function z square is analytic. Idu yavadu cold agutte? For an analytic function only this is true. Proof. Let w equals f of z equals u plus iv be analytic function. When I say that it is analytic, it should satisfy CR equation. So because u plus iv is analytic, it satisfies CR equation. See, what are CR equations? Delta u by delta x equals delta v by delta y, and delta u by delta y equals minus delta v by delta x. Yakandre analytic anta bantu andre CR equation satisfy agutte. So function is analytic ಅಂತ ಅಲ್ಲಿ ಇದರಲ್ಲಿ ಥಿಯರಮಿನ ಸ್ಟೇಟ್ಮೆಂಟ್ ಅಲ್ಲೇ ಕೊಟ್ಟಿದೆ, ಅನಾಲಿಟಿಕ್ ಫಂಕ್ಷನ್. ಅದರಿಂದ CR equations ಅನ್ನು ಯೂಸ್ ಮಾಡಬಹುದು. What are the two CR equations? Delta u by delta x equals delta v by delta y, and delta u by delta y equals minus delta v by dx. So this is CR equation. Suppose the second order partial derivatives of u and v exist and are continuous. ಅಲ್ವಾ? ಯಾಕಂದ್ರೆ ಲ್ಯಾಪ್ಲೇಸ್ ಈಕ್ವೇಶನ್ ಬರಬೇಕು ಅಂದ್ರೆ ಹಾರ್ಮೋನಿಕ್ ಪ್ರೂವ್ ಮಾಡಬೇಕು ಅಂದ್ರೆ ಲ್ಯಾಪ್ಲೇಸ್ ಈಕ್ವೇಶನ್ ಬರಬೇಕು. ಲ್ಯಾಪ್ಲೇಸ್ ಈಕ್ವೇಶನ್ ಬರಬೇಕು ಅಂದ್ರೆ ಏನೇನು ಬರಬೇಕು? ಸೆಕೆಂಡ್ ಆರ್ಡರ್ ಪಾರ್ಷಿಯಲ್ ಡೆರಿವೇಟಿವ್ ಡೆಲ್ಟಾ ಸ್ಕ್ವೇರ್ ಯು ಬೈ ಡೆಲ್ಟಾ ಎಕ್ಸ್ ಸ್ಕ್ವೇರ್, ಡೆಲ್ಟಾ ಸ್ಕ್ವೇರ್ ಯು ಬೈ ಡೆಲ್ಟಾ ವೈ ಸ್ಕ್ವೇರ್ ಅನ್ನೋದು ಬೇಕು. ಅದು ಬರಬೇಕಾದ್ರೆ ಇವೆರಡೂ ಬೇಕಾಗಿದ್ದರಿಂದ, ಇವೆರಡು ಎಕ್ಸಿಸ್ಟ್ ಆದ್ರೂ ಮಾತ್ರ ನಾವು ಅದನ್ನ ಮಾಡಕ್ ಸಾಧ್ಯ. ಸೊ ಅದನ್ನ ಎಕ್ಸಿಸ್ಟ್ ಅಂತ ಅಸ್ಯೂಮ್ ಮಾಡೋಣ. ಲೆಟ್ ಅಸ್ ಸಪೋಸ್ ದಟ್ ದಿ ಸೆಕೆಂಡ್ ಆರ್ಡರ್ ಪಾರ್ಷಿಯಲ್ ಡೆರಿವೇಟಿವ್ಸ್ ಆಫ್ ಯು ಅಂಡ್ ವಿ exist and are continuous. Next, you have two equations. In CR equations, error equations. One equation is, so what is one equation? Delta u by delta x equals delta v by delta. You take this equation now. So if you take this equation, is one the equation first order. ಈ ಈಕ್ವೇಶನ್ ತಗೊಂಡಾಗ ಡಿಫರೆನ್ಶಿಯೇಟಿಂಗ್ ದಿ ಅಬೋವ್ ಈಕ್ವೇಶನ್ಸ್ ವಿತ್ ರೆಸ್ಪೆಕ್ಟ್ ಟು ಎಕ್ಸ್ ಅಂಡ್ ಆಲ್ಸೋ ವಿತ್ ರೆಸ್ಪೆಕ್ಟ್ ಟು ವೈ ಪಾರ್ಷಿಯಲಿ ಅಂಡ್ ಆಡಿಂಗ್. ಫಸ್ಟ್ ವಿತ್ ರೆಸ್ಪೆಕ್ಟ್ ಟು ಎಕ್ಸ್ ಇದನ್ನು ಡಿಫರೆನ್ಶಿಯೇಟ್ ಮಾಡಿ, ಎರಡೂ ಕಡೆ ಮಾಡಬೇಕು, ಒಂದ್ ಕಡೆ ಮಾಡಿದ್ರೆ ಬರಲ್ಲ. ಯು ಹ್ಯಾವ್ ಟು ಡಿಫರೆನ್ಶಿಯೇಟ್ ಬೋತ್ ಸೈಡ್ಸ್ ಪಾರ್ಷಿಯಲಿ ವಿತ್ ರೆಸ್ಪೆಕ್ಟ್ ಟು ಎಕ್ಸ್. ಈ ಕಡೆ ಡಿಫರೆನ್ಶಿಯೇಟ್ ಮಾಡಿದಾಗ ಏನಾಗುತ್ತೆ ಇದು ಅಂದ್ರೆ ಡೆಲ್ಟಾ ಸ್ಕ್ವೇರ್ ಯು ಬೈ ಡೆಲ್ಟಾ ಎಕ್ಸ್ ಸ್ಕ್ವೇರ್ ಆಗುತ್ತೆ ಅಲ್ವಾ. ನೆಕ್ಸ್ಟ್ ಇದರ ಡಿಫರೆನ್ಶಿಯೇಷನ್ ಏನು, ಪಾರ್ಶ್ ವಿತ್ ರೆಸ್ಪೆಕ್ಟ್ ಟು ಎಕ್ಸ್ ಮಾಡಿದಾಗ ಇಲ್ಲಿ ಬರ್ದಿದೆ ನೋಡಿ, ಡೆಲ್ಟಾ ಸ್ಕ್ವೇರ್ ವಿ ಬೈ ಡೆಲ್ಟಾ ಎಕ್ಸ್ ಡೆಲ್ಟಾ ವೈ. ಹಾಗೆ ಇದನ್ನು ವಿತ್ ರೆಸ್ಪೆಕ್ಟ್ ಟು ಯಾವ್ದು ಮಾಡಬೇಕು, ಯು ಹ್ಯಾವ್ ಟು ಡಿಫರೆನ್ಶಿಯೇಟ್ ದಿ ಸೆಕೆಂಡ್ ಈಕ್ವೇಶನ್ ವಿತ್ ರೆಸ್ಪೆಕ್ಟ್ ಟು ವೈ. ಸೊ ಇದನ್ನ ವಿತ್ ರೆಸ್ಪೆಕ್ಟ್ ಟು ವೈ ಮಾಡ್ಬೇಕೀಗ. ಯಾವುದನ್ನ, ಸೆಕೆಂಡ್ ಈಕ್ವೇಶನ್ ವಿತ್ ರೆಸ್ಪೆಕ್ಟ್ ಟು ವೈ ಮಾಡಿದಾಗ ಏನಾಗುತ್ತೆ, ಡೆಲ್ಟಾ ಸ್ಕ್ವೇರ್ ಯು ಬೈ ಡೆಲ್ಟಾ ವೈ ಸ್ಕ್ವೇರ್ ಆಗುತ್ತೆ. ಇಲ್ಲೇನಾಗುತ್ತೆ, ವಿತ್ ರೆಸ್ಪೆಕ್ಟ್ ಟು ವೈ ಮಾಡಿದಾಗ ಮೈನಸ್ ಡೆಲ್ಟಾ ಸ್ಕ್ವೇರ್ ವಿ ಬೈ ಡೆಲ್ಟಾ ಎಕ್ಸ್ ಡೆಲ್ಟಾ ವೈ ಆಗುತ್ತೆ. ಅಥವಾ ಡೆಲ್ಟಾ ವೈ ಡೆಲ್ಟಾ ಎಕ್ಸ್ ಬೇಕಾದ್ರೂ ಹೇಳ್ಬೋದು, ಡೆಲ್ಟಾ ಎಕ್ಸ್ ಡೆಲ್ಟಾ ವೈ ಬೇಕಾದ್ರೂ ಹೇಳ್ಬೋದು. ಯಾಕೆ ಒಂದು ರಿಸಲ್ಟ್ ಇದೆ, ಕಂಟಿನ್ಯೂಸ್ ಪಾರ್ಷಿಯಲ್ ಡೆರಿವೇಟಿವ್ಸ್ ಇದ್ದಾಗ ಆ ಆರ್ಡರ್ನ ಬದಲಾಯಿಸಿ ಬರೀಬಹುದು ಅಂತಿದೆ. ಬೇಡ, ಅದೇನು ಬೇಕಿಲ್ಲ. ಫಸ್ಟ್ ನೋಡಿ, ಈ ಮೊದಲನೇ ಈಕ್ವೇಶನ್ನ ವಿತ್ ರೆಸ್ಪೆಕ್ಟ್ ಟು ಎಕ್ಸ್ ಡಿಫ್ರೆನ್ಶಿಯೇಟ್ ಮಾಡ್ತೀರಾ, ನೆಕ್ಸ್ಟ್ ಇದನ್ನ ವಿತ್ ರೆಸ್ಪೆಕ್ಟ್ ಟು ವೈ ಡಿಫ್ರೆನ್ಶಿಯೇಟ್ ಮಾಡ್ತೀರಾ, ಎರಡನ್ನು ಆ್ಯಡ್ ಮಾಡ್ತೀರಾ. ಆ್ಯಡ್ ಮಾಡಿದ್ರೆ ಏನಾಗುತ್ತೆ ನೋಡಿ, ಡೆಲ್ಟಾ ಸ್ಕ್ವೇರ್ ಯು ಬೈ ಡೆಲ್ಟಾ ಎಕ್ಸ್ ಸ್ಕ್ವೇರ್ ಪ್ಲಸ್ ಡೆಲ್ಟಾ ಸ್ಕ್ವೇರ್ ಯು ಬೈ ಡೆಲ್ಟಾ ವೈ ಸ್ಕ್ವೇರ್. ಇಲ್ಲೇನಾಗಿರುತ್ತೆ, ಡೆಲ್ಟಾ ಸ್ಕ್ವೇರ್ ವಿ ಬೈ ಡೆಲ್ಟಾ ಎಕ್ಸ್ ಡೆಲ್ಟಾ ವೈ ಆಗಿರುತ್ತೆ. ಇಲ್ಲೇನಾಗಿರುತ್ತೆ, ಡೆಲ್ಟಾ ಸ್ಕ್ವೇರ್ ವಿ ಬೈ ಡೆಲ್ಟಾ ವೈ ಡೆಲ್ಟಾ ಎಕ್ಸ್ ಅಥವಾ ಡೆಲ್ಟಾ ಎಕ್ಸ್ ಡೆಲ್ಟಾ ವೈ, ಹೇಗೆ ಬೇಕಾದ್ರೂ ಬರೀಬಹುದು. ಮೈನಸ್ ಬರುತ್ತೆ, ಯಾಕೆಂದ್ರೆ ಆ್ಯಡ್ ಮಾಡಿದಾಗ ಇಲ್ಲಿ ಇಲ್ಲೊಂದು ಮೈನಸ್ ಇದ್ದಿದ್ರಿಂದ ಆ ಮೈನಸ್ ಇಲ್ಲಿ ಕ್ಯಾರಿ ಆಗುತ್ತೆ. ಈಗ ಇವೆರಡು ಸೇಮ್ ಇದೆ, ಇವೆರಡು ಸೇಮ್ ಇದ್ರೆ ಅದನ್ನ ಕಳೆದಾಗ ಝೀರೋ ಅಂದರೆ ಡೆಲ್ಟಾ ಸ್ಕ್ವೇರ್ ಯು ಬೈ ಡೆಲ್ಟಾ ಎಕ್ಸ್ ಸ್ಕ್ವೇರ್ ಪ್ಲಸ್ ಡೆಲ್ಟಾ ಸ್ಕ್ವೇರ್ ಯು ಬೈ ಡೆಲ್ಟಾ ವೈ ಸ್ಕ್ವೇರ್ ಇಸ್ ಝೀರೋ. ಅಂದರೆ ಲ್ಯಾಪ್ಲೇಸ್ ಈಕ್ವೇಶನ್ ಡೆಲ್ಟಾ ಸ್ಕ್ವೇರ್ ಯು ಇಸ್ ಝೀರೋ, ಅಂದರೆ ಯು ಇಸ್ ಹಾರ್ಮೋನಿಕ್. ಏನು ಪ್ರೂವ್ ಮಾಡಬೇಕಾಗಿತ್ತು ನಾವು, ಯುನು ಹಾರ್ಮೋನಿಕ್ ವಿನು ಹಾರ್ಮೋನಿಕ್ ಅಂತ ಪ್ರೂವ್ ಮಾಡ್ಬೇಕಂದ್ರೆ ಇದು ಯು ಇದು ವಿ ಇದ್ದಾಗ ಅಲ್ವಾ, ಇದು ಯು ಇದು ವಿ, ಇದೊಂದು ಅನಾಲಿಟಿಕ್ ಫಂಕ್ಷನ್. ಈ ಅನಾಲಿಟಿಕ್ ಫಂಕ್ಷನ್ ಅಲ್ಲಿ ರಿಯಲ್ ಪಾರ್ಟ್ ಹಾರ್ಮೋನಿಕ್, ಇಮ್ಯಾಜಿನರಿ ಹಾರ್ಮೋನಿಕ್ ಪಾರ್ಟ್ ಆಸ್ ಆಲ್ಸೋ ಹಾರ್ಮೋನಿಕ್ ಅಂತ ಪ್ರೂವ್ ಮಾಡಬೇಕಾಗಿತ್ತು. ಒಂದು ಪ್ರೂವ್ ಮಾಡಿದ್ವಿ, ಈಗ ಯು ಇಸ್ ಹಾರ್ಮೋನಿಕ್. ಅದೇ ಥರ ವಿ ಇಸ್ ಹಾರ್ಮೋನಿಕ್ ಅಂತ ಈಗ ನೆಕ್ಸ್ಟ್ ಪ್ರೂವ್ ಮಾಡಬೇಕು. ಅವಾಗ ಏನು ಮಾಡಬೇಕು, ಮೊದಲನೇ ಈಕ್ವೇಶನ್ ವಿತ್ ರೆಸ್ಪೆಕ್ಟ್ ಟು ವೈ ಮಾಡಿ, ಎರಡನೇ ಈಕ್ವೇಶನ್ ಸಿ ಆರ್ ಈಕ್ವೇಶನ್ ಅಲ್ಲಿ ಮೊದಲನೇ ಈಕ್ವೇಶನ್ ವಿತ್ ರೆಸ್ಪೆಕ್ಟ್ ಟು ವೈ ಮಾಡಿ, ಎರಡನೇ ಈಕ್ವೇಶನ್ ವಿತ್ ರೆಸ್ಪೆಕ್ಟ್ ಟು ಎಕ್ಸ್ ಪಾರ್ಷಿಯಲಿ ಡಿಫ್ರೆನ್ಶಿಯೇಟ್ ಮಾಡಿ ಕಳಿಬೇಕು. ಆ್ಯಡ್ ಮಾಡೋದಲ್ಲ, ಸಬ್ಟ್ರಾಕ್ಟ್ ಮಾಡಬೇಕು. ಮೊದಲನೇ ಈಕ್ವೇಶನ್ ಅಂದರೆ ಇದನ್ನು ವಿತ್ ರೆಸ್ಪೆಕ್ಟ್ ಟು ವೈ ಮಾಡಬೇಕು. ಅವಾಗ ಡೆಲ್ಟಾ ಸ್ಕ್ವೇರ್ ಯು ಬೈ ಡೆಲ್ಟಾ ಎಕ್ಸ್ ಡೆಲ್ಟಾ ವೈ, ಇದನ್ನು ವಿತ್ ರೆಸ್ಪೆಕ್ಟ್ ಟು ವೈ ಮಾಡಿದಾಗ ಡೆಲ್ಟಾ ಸ್ಕ್ವೇರ್ ವಿ ಬೈ ಡೆಲ್ಟಾ ವೈ ಸ್ಕ್ವೇರ್ ಆಗುತ್ತೆ. ಹಾಗೆ ಇದನ್ನು ವಿತ್ ರೆಸ್ಪೆಕ್ಟ್ ಟು ಎಕ್ಸ್ ಮಾಡಬೇಕು, ಇದನ್ನು ಡೆಲ್ಟಾ ಸ್ಕ್ವೇರ್ ಯು ಬೈ ಡೆಲ್ಟಾ ಎಕ್ಸ್ ಡೆಲ್ಟಾ ವೈ ಮೈನಸ್ ಡೆಲ್ಟಾ ಸ್ಕ್ವೇರ್ ವಿ ಬೈ ವಿತ್ ರೆಸ್ಪೆಕ್ಟ್ ಟು ಎಕ್ಸ್ ಮಾಡಬೇಕಲ್ವಾ, ಡೆಲ್ಟಾ ಸ್ಕ್ವೇರ್ ಎಕ್ಸ್ ಡೆಲ್ಟಾ ಎಕ್ಸ್ ಹೋಲ್ ಸ್ಕ್ವೇರ್. ಈಗ ಕಳಿಬೇಕು ಅಂದರೆ, ಯಾಕೆ ಕಳಿಬೇಕು ಅಂದರೆ ಇಲ್ಲಿ ಮೈನಸ್ ಬಂದಿದೆಯಲ್ಲ, ಅದು ಪ್ಲಸ್ ಆಗಬೇಕು. ಯಾಕಂದ್ರೆ ಸಿ ಆರ್ ಈ ಲ್ಯಾಪ್ಲೇಸ್ ಈಕ್ವೇಶನ್ ಅಲ್ಲಿ ಪ್ಲಸ್. ಸೊ ಹಾಗೆ ಮಾಡಿದಾಗ ವಾಟ್ ವಿಲ್ ಗೆಟ್ ಇಸ್, ಇಲ್ಲಿ ಡೆಲ್ಟಾ ಇದನ್ನು ಪ್ಲಸ್ ಮಾಡ್ಕೊಳ್ಳಿ, ಇದನ್ನು ತಪ್ಪಾಗಿದೆ ನೋಡಿ, ಡೆಲ್ಟಾ ಸ್ಕ್ವೇರ್ ವಿ ಬೈ ಡೆಲ್ಟಾ ವೈ ಸ್ಕ್ವೇರ್ ಪ್ಲಸ್ ಯಾವುದು ಈ ಟರ್ಮ್ ಇದೆಯಲ್ಲ ಅದು ಪ್ಲಸ್ ಆಗಬೇಕು, ಇದರಲ್ಲಿ ತಪ್ಪಾಗುತ್ತೆ, ಇದು ಪ್ಲಸ್. ಓಕೆ, ಡೆಲ್ಟಾ ಸ್ಕ್ವೇರ್ ವಿ ಬೈ ಡೆಲ್ಟಾ ಎಕ್ಸ್ ಸ್ಕ್ವೇರ್ ಪ್ಲಸ್ ಡೆಲ್ಟಾ ಸ್ಕ್ವೇರ್ ವಿ ಬೈ ಡೆಲ್ಟಾ ವೈ ಸ್ಕ್ವೇರ್. ನಿಮ್ಗೆ ಅನುಮಾನ ಬಂದರೆ ಸಪ್ರೇಟ್ ಬರ್ಕೊಂಡು ಮಾಡಿ ನೋಡಿ, ಅದು ಗೊತ್ತಾಗುತ್ತೆ ನಿಮಗೆ. ಸೊ ದೇರ್ ಫಾರ್ ದಿಸ್ ಮೈನಸ್ ದಿಸ್ ಸೇಮ್ ಟರ್ಮ್ ಆಗುತ್ತೆ ಝೀರೋ. ದೇರ್ ಫಾರ್ ವಿ ಇಸ್ ಹಾರ್ಮೋನಿಕ್. ದಟ್ ಈಸ್ ರಿಯಲ್ ಅಂಡ್ ಇಮ್ಯಾಜಿನರಿ ಪಾರ್ಟ್ಸ್ ಆಫ್ ಅನ್ ಅನಾಲಿಟಿಕ್ ಫಂಕ್ಷನ್ ಆರ್ harmonic. Any doubts in the proof of this theorem? Do you have any doubts? Ashita D, unmute yourself.
Yes, sir.
Do you have any doubts?
Yes, sir.
Other doubt is
No,
yeah.
sir. Illa, sir.
Illa. Okay, the time Zoom time is running out. So therefore, I shall conclude this class and thank you one and all.
Thank you, sir.
Okay, right.